Today I am talking to Jonathan Boyle from NAG. NAG is one of the partners in the POP project. Performance Optimization and Productivity, or in short POP, is a center of excellence in HPC funded by EU. POP focuses on parallel code. So Jonathan, can you tell us a bit more why code matters so much that EU funds a center of excellence to take care of it?
Hi, Fouzhan. Yeah, I think it's an interesting question, and I think it's really important to step back and consider what code represents for most businesses. And I would argue that code represents value in a very immediate sense. And of course, it's important to consider there's a cost associated with that value.
Can you say a bit more? What do you mean by code representing value?
Okay, so what I mean is that for many organizations, code is the lifeblood of the business, and it's going to be the foundations upon which their commercial value and financial income is built. And there's many different ways that this is true. For example, code could represent some valuable intellectual property, or it could offer something unique to the world in terms of service offerings, or it could underpin an organization's reputation. And I think it's interesting that code is kind of invisible. It's quite hard to see. So it can be quite hard to assess the quality of code in the same way you might be able to assess the quality of some kind of tangible physical asset. So code could be creaky, old, inefficient. It could be holding back a business. And yet this might not be at all obvious. Well, it might not be obvious until it's far too late to do anything about it. And in the POP project, the aspect of value that we care about is the execution speed and the parallel performance. And we can help organizations with this, and our help can lead to big cost savings.
We come across those kind of old inefficient codes that look like they have been optimized for a different era of computation very often in POP, don't we? So inefficiency and a slow execution costs money in a very direct way. Can you say a little bit more about this?
Yeah, I mean, there's many different ways in which inefficient, slow code can cost money. For example, companies will lose business to competitors if their code runs slower. Obviously, organizations, but they want code that runs fast. So if you're going to buy code, you're going to choose the code that runs fastest, if all other things being equal. Also, time spent running inefficient, slow code can increase electricity costs and cloud bills. If you're spending time waiting for computation results, that's going to cost you money in terms of lost productivity. And even if your code runs fast enough, there could still be lost business opportunities which you might be able to realize if your code ran faster. You might be able to offer some completely novel solutions which weren't available with the slower code. And another cost that's important to think about is the cost of training your staff to learn the parallel software engineering skills that are required to write high quality parallel code. And these problems are all things that POP can help with.
Basically, nowadays, optimal use of hardware means parallel code and parallel execution. There is no shortcut around it. And we have different type of hardware that we can use for parallel execution. It can be multi-core processors that are available on any desktop or in laptops. There are accelerators, or they're using clusters using multiple nodes connected with networks. So can you say why is it so difficult to engineer efficient parallel code? Like we have so many hardwares. What's the problem now?
Yeah, I mean, my experience is that parallel code is often quite difficult to write, but generally it's horrible to analyze performance issues. Part of that's because of the complexity of the code. Often there'll be thousands of lines of code, hundreds of files, multiple execution paths, behavior that might change depending on the problem size of the hardware. But also, as you said, the hardware is complex as well these days. We've got many core, multi-core, multiprocessors, parallel file I/O, perhaps GPUs. And this means that it can be very hard to relate hardware issues to the source code. I've been writing and running parallel finite element software for years before I joined the POP project and learned the skills associated with analysing parallel performance. And I realise now I was very naive previously in my understanding of how to write performant code and analyse performance.
So it's very interesting that you have the experience of being both code developer and now looking at the code from different perspective, trying to identify the performance issues and helping the developers. So with having this experience, how do we get there? How we get to have high quality and low cost parallel code?
Yes, good question. And I think based on my experience now, you really do need a software engineer who's an expert in parallel computing. And in POP, we have many experts in this area. And because we're funded by the EU, we can offer help to organizations for free. So in POP, we can help organizations improve code speed and efficiency.
So POP is a center of excellence in HPC, and efficiency is very important. It has always been important, but with, the exascale machines become a reality very soon. Some people think that that's all where the focus is. And exascale is very important for some area of research or some users, but there are still a lot of people or users that benefit from using HPC machines, but they don't need that level of capabilities that exascale brings in. So can you give us example of, have you worked with people with that type of users and how POP has helped them?
Yes, many of the codes that POP help with are high-performance computing codes. They're designed to run on hardware with many thousands of processors. And when we reach exascale, that code will have to run on exascale hardware as well. So to give you an example, in POP, I analyze the performance of some density functional theory code, DFT code, that have been designed to run on multiple processors, hundreds, thousands of processors potentially. And the code is very nicely written, but the analysis of the performance I undertook identified some things the developers hadn't realized, and identified some inefficient use of Intel's MKL libraries, identified some opportunities where computation and MPI communication could be overlapped. And I also identified some MPI data transfer that wasn't necessary. So I did this analysis, and in POP we provide this performance analysis for free. And then another service we offer for free is a service where we actually modify the client's codes. So I implemented some modifications to the code to improve performance. And by using the information from the analysis, I was able to improve the code significantly. So there was like a 4 times speed up for the region of code I was working on, which I think is quite significant.
Yeah, 4 times a speed up means a lot of saving either in, cloud bills or in time. So what about the other type of users, that very other end of spectrum? So not people that necessarily run their code on HPC machines, but they have parallel codes and they run it on their workstation or even on their laptops. Have you worked with that kind of codes or users as well?
Oh yes, there's been a few clients supplied for POP services where they're writing code using OpenMP. So this is code designed to be parallel but running on laptops, desktops, workstations where there's shared memory. And when I analysed this code, I identified significant load imbalance inside the OpenMP parallelization, and also some serial execution outside the OpenMP, which is impacting performance as described by Amdahl's law. So this information was really useful for the client. He was able to modify the code and improve performance. And then something else I identified was that the code was making inefficient use of memory. There were some memory bottlenecks that were affecting performance. And with this code, I rewrote some of the code to improve memory accesses, and this gave a 2 times speed up. So another significant speed up.
Yeah, absolutely. And it's also very interesting because a lot of people might think that the person who can improve a code is the person who wrote it, but that's not necessarily true with the examples that you have been given. Most of the time, especially even parallel codes, the people who are expert in performance looks to, could offer a lot of help. So the examples you have given are you have been working with code developers. What about code users? How POP can help the people who use a code, but they haven't developed it?
Yeah, we do get people applying for POP that are using other people's codes, and they want to understand why their computation is running slowly or inefficiently. So we do analyze codes for users of code, and the code users find this information useful because it helps them understand if they're actually getting optimal performance from the code, or whether there might be a more efficient way, a faster way of getting the results they need. For example, they might want to consider using a different code. And also sometimes the code users take the information we give them and use that to talk to the code developers and ask them to make improvements to the code. So even code users understanding performance of the code they're using can be useful information.
Yeah. Thank you, Jonathan, for your time. And in this note, if you work with parallel code, and whether you are a developer or the user and you wonder about the performance of the code, then you know how to get the help. Just visit the pop-up site and fill in the service request, and people would be in touch with you. Thank you.
Thanks, Fouzhan.